Hello friends, Jai Hind, Jai Bharat. Today we will learn the topic simple harmonic motion, which is related to the chapter Oscillation 11 Science. And our topic is comparison of different kind simple harmonic motion. Okay. On the three bases we will compare simple harmonic motion. First is amplitude, second is phase, and third is time period. In the first case, we will change the amplitude of the simple harmonic motion. Phase and time period will remain same. In the second case, phase or phase constant will be changed, but the amplitude and time period will remain same. And in the third case, time period t will be different, but the amplitude and phase or phase constant will remain the same. Now the first case, here amplitude change, but phase and time period same. Okay, we have two pendulums. Our first pendulum is oscillating, barabar, in such a way that its maximum amplitude on both sides is supposed to be 2 unit. Okay, for 2 unit amplitude we are start counting the oscillation from plus a position. So in one period of time it will gain its firstly positions. In second case, same thing happen, but here the amplitude is 3 unit. Okay, the area cover from equilibrium position to extreme level is 2 unit in the first case, but in the second case the area cover from the equilibrium position to the extreme position is 3 unit. In both the cases we start the oscillations from plus a position. Also here in both cases the time taken for one oscillation is same, t. In both cases the time taken for one oscillation is t. It means in the first case if we start counting oscillations from plus a, so in one oscillation if it is take 4 seconds, so in second case also, or in second pendulum also, for one oscillation it will takes 4 seconds. So here in both the cases time period is same, t is equal to 4 seconds both cases. Phase or phase constant is same, we are starting from plus a position, but here the amplitude is different. So in 4 seconds, 1 2 3 4, in 4 seconds, in one period of time it will cover 2a distance, which is 4 unit. 2 plus 2, 4 unit. Here in one period of time from plus a to again plus a. So 1 second, 2 second, 3 second, 4 second. In 4 second, in one period of time, it will cover total 6 unit distance. Okay, 3 unit plus 3 unit. It will cover 6 unit distance. So I have to draw both the cases on the graph. Here in the second case, instead of amplitude A, I will denote it as B, plus B, here minus B. Okay, for the second case. So what will happen here? For the first case, it is our equilibrium position. Okay, the simple harmonic motion, I denote it in the y direction. So it is 1 unit, it is 2 unit on either side, 1 unit, 2 unit. It is plus a, it is minus a. Okay, time period t is equal to 4 seconds in both cases. So 1 second, 2 second, 3 second and 4 second. So in 4 second it finishes it one oscillation. So it will become like this. Okay, in one period of time. Now for the second case, here the amplitude, we will change the amplitude, but the phase or phase constant and time period will remain same. So our amplitude will be 3 unit. It is 1 unit, it is 2 unit, and here is 3 unit, and we denote it as plus B. 1 unit, 2 unit and 3 unit, it is minus B. So for one period of time, our wave representation is like this. Okay, so here time period is also same. We start oscillations from plus A or plus B position. Okay, extreme or positive side. So both phase and time period is same, but amplitude is changed. So now on both the cases, if I have to write the equation, so the equation will become, for the first situation, our equation will become xt is equal to a cos omega t plus phi. Here we started oscillation from extreme value, extreme position. So our phase constant will become 0. So it will become a cos omega t. For the second case, this with red pen. Okay, our equation will become xt is equal to b cos omega t plus phi. Same situation, phi is equal to 0, b cos omega t. Okay, now in the second case, we will change in phase constant, amplitude and time period will remain same. Okay, so for the second case, Firstly, we will count the oscillations from plus A position. So as we will count the oscillation from the plus A position, so if the time period is 8 seconds, so our graphical representation should become like this way. One, 2, 3, 4, 5, 6, 7 and 8. Okay, it is plus A, it is minus A. For one oscillation, it will take 8 seconds. Okay, so our graphical representation should become like this. Now, in the second case, with same pendulum and with same periodic time, but we start counting the oscillations from this position. It is between the equilibrium position and plus A position, and the direction of the oscillation at firstly is this way. So it means the bob is go on plus A position, again come back, and again equilibrium position, then minus A, again equilibrium position, then at this position. So we can say at t is equal to 0, our bob or particle is at in between equilibrium position and plus A. It is equilibrium position, it is plus A. So at t is equal to 0, our particle is at this position. Okay, at 1 second it will reach plus A, at 1 second it will reach at plus A position, at 2 seconds again this position. Okay, at 3 seconds it will reach equilibrium position, at 4 and 5 seconds it will reach minus A. So at 5 seconds it will reach at minus A. At 6 and 7 again equilibrium position, at 6 and 7 again equilibrium position. At 8 seconds, for this, if we count from this position, at 8 seconds it will reach the same position. Okay, so one period will finish. So at 8 seconds it will reach from in between equilibrium position and plus A position. It is equilibrium position and plus A in between position. So again it will reach at 8 seconds it will reach this position. So our graph will become like this. Okay, in the both case time period is same, amplitude is also same, but the phase is different. Now look here, if we start oscillation from this position, so here no phase. Okay, so phi is equal to 0. But in the second case, we start oscillation from this position in between equilibrium and plus A, but it will go upside. Okay, so here our phase is equal to, it is pi by 2, it is pi by 2, so it is pi by 4. So our phase constant is minus pi by 4. for second case. For the first case, our phase constant is 0. Okay. Now for the third case, time period t is different, amplitude and phase remain same. Okay, we will see this. We have two different pendulum. In the first pendulum, for one oscillation, it will take t is equal to 4 seconds. In the second case, for one oscillation, it will take t is equal to 6 seconds. Okay, if I have to represent both the oscillation in the same graph, so it will become like this way. Plus A, minus A, equilibrium position, 1, 2, 3 and 4. For the first case, in 4 seconds, one oscillation will complete. So 2, 3 and 4. In the second case, it will take 6 seconds for one oscillations. Okay, so what is the frequency? F is equal to 1 upon T. For the first case, it will become 1 upon 4 for first case, but for second case, it will become, frequency will become 1 upon 6 for the second case. Now it is 1.5, 3, 4.5 and 6. Okay, so our oscillations will become like this. For the second case, 3, 4 and 5. Here t is equal to 4 seconds and in second case t is equal to 6 seconds. Amplitude is same, our phase constant is same. We start from plus A position, but the time period will become change, so our graph will become like this way. Thank you one and all.